aliasing of sinusoidal signals. We've got two signals here. This is the continuous spectrum, okay, because it's in F and it's in kilohertz. Let's just say we sample at Fs equal to 10 kilohertz. Now with your newfound knowledge of the DTFT, you should be able to draw the spectrum super quick. Okay, so the spectrum for this one, 3 will move to where? What's the value here? 3 kilohertz goes to, oh sorry, this is in terms of F omega. 3 goes to where? What happens? The spectrum, the scale of this axis just gets divided by the sampling frequency, and I repeat it periodically. So what happens at 3 now happens at 3 over 10 and at minus 3 over 10, and then it repeats periodically. So at 1 we have another one, and then this thing would be at, what's that, 7 over 10, and this thing would be at 13 over 10. Okay, and similar on that side. Dunk. You happy? Awesome. Same thing happens here. So what happened here? Very easy. 13 goes to 13 over 10. Okay. 13 over 10. This thing goes to minus 13 over 10. So this is 13 over 10. And this is minus 13 over 10. And then things around, this is 1, it also repeats. This is 1 and this is minus 13 over 10. So from 1 I go 13 over 10 negative. That lands there. From this side I go dunk, dunk. Okay, from somewhere on that side I end up there, and from somewhere on that side I end up there. What's the difference between these two spectra? Nothing. They're the same signal. Okay, it's actually because we're getting aliasing with this signal. What's happening here is we've got two sine waves, one going slowly and we sample it and we get it samples doof, 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 doof. The other one is pulsing really quickly and we get its samples doof, 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 and we end up with exactly the same signal. Very frustrating. Okay, let's quickly do a demo of aliasing. So this is an interesting one. This is an interesting one because what we do here is we listen to a little signal that increases with frequency. Okay, so this signal starts at some low frequency. It's also a non-stationary signal, so it's a little bit weird, but okay. It starts at a low frequency and then it goes from 1 kilohertz to 2 kilohertz to 3 kilohertz to 4 kilohertz, and it's basically moving up. It's getting more and more. So this impulse is shooting that side in the frequency main. This one is shooting that side. Okay? You can see it on the little plot here. You start slow and then you start to speed up. Okay? And the signal then sounds something like this. Okay, some of you might, I can't hear the last part, I think, because my son shouts in my ears and then I become deaf. Okay, so, but what happens when you sample this thing, so this is if it's not a sampled signal, right? This thing moves up here and it just goes to wherever I stop in frequency. But let's now say we sample this thing. So what will happen then is when we sample it, we get this copy, basically, it becomes a periodic signal. Okay, and then if I increase this frequency, what's happening is this one is also moving that way. Everyone with me? If we sample high enough, it's fine. If we sample high enough, we will stop like at that point and at that point at the highest frequency of the signal. But if we don't sample high enough, what's going to happen is this one is going to go into that side. Okay, and we're going to basically hear that copy going into the part of the spectrum that's audible. Okay, so that's the original signal. You've heard it. This is when we sample slower, okay, at half the original rate. Okay, so you know what's happening now is this impulse has just moved in and it's basically moving rip, and it sounds like the frequency is going down, basically. If we make Fs even slower, then what's going to happen is we're going to see the first impulse moving past, and then the other one is also going to come in. Okay, so we're going to like hear multiple copies of this. So if we do it at 4, okay, so it's these impulses going past, and then at 8, you have this. It's pretty cool. Does this make sense? Just nod? Okay, so you actually see on real world signals, that we're not talking nonsense.